How are you, folks? Enzo DiCostanzo, clinical professor of economics and finance, St. Peter's University in Jersey City, New Jersey. Coming to you today from Essex County, New Jersey, where we generally make these videos. And we had an extensive discussion this morning on net present value and a real estate investment, and coming in with a certain amount of dollars and exiting, and what the return was going to be, and distinguishing between sort of the finance analysis of that and the accounting analysis of that. And unfortunately, both of them do have profit margins, and those profit margins are the same, but just sort of how you think about them. The finance is a little more scientific. The accounting is a little more dollars in the shoebox kind of an example that I use in class very often. We're going to extend that model into a much more complicated real estate model where there's a bunch of cash flows and there's more years, and we're going to get right to it. Okay, folks, so we worked this morning on this net present value model. We extensively spent time on this. You came in with a 350,000, and then it was 355. It moved a bit, and you exited 400,000. So we spent a lot of time this morning on that. We got through it. It was a lot of talking for about 200 lines or 150 lines of model or so. So we're going to step it up a bit. Since you have that experience, the next one is the valuing long-lived projects. And doing evaluation is really the biggest part of my work and what I think about. What's the fair value of something, property, an asset, a situation, an opportunity, hanging a number on that and trying to anticipate cash flows. That's a big part of convincing people to make this investment, make that investment type of thinking. Okay, so we're going to get right to that. And like I said, I have my little sort of, I work all of these before. I don't just get on video and say, oh, let me figure out what to do. I work these all before. We've been working with an opportunity cost of about 7%, which is right there. And now this project has changed a bit. It says your approach on a possible tenant who's prepared to pay rent at your office block for 3 years. So you're buying a certain amount of property. You've estimated your cash flow annual for the next 3 years at about 25,000. This would increase the initial investment from, I'm saying those are the cash flows, and then you'd have to expand. This 25,000 has nothing to do with the annual number. Initially, this was a $350,000 real estate investment project. Now it's bumped up to 375. So it's 350 plus 25. And then you're forecasting that you could sell that building at 450 in, I think it's, at the end of 3 years, looking at our model at the end of 3 years. So you have to increase your initial investment. You have 3 cash flows plus exiting the venture, which now with your additional investment is a little bit higher than the 400,000 that we spoke about this morning. That's about 450,000. Okay, so, and again, this whole thing, and we'll just bolt HH, and we've discussed this before. We're just getting rid of the fill in that particular manner. So this is minus 375, 1, 2, 3. It looks like that. That's, you come in with that amount of money, and time 0 is today type of situation. And what we're going to do is we're going to type in. We're not going to just group it all in at the end like happens so often. I've seen textbooks and things of that nature. You're getting 3 distinctive cash flows for like a rent revenue type of a thing at 25,000 a year. Then you're going to exit at 450. And so many times you see these models with 475, and then you got to sort of back it out in your head type of a thing. But yeah, we're forecasting the sale price of the building. And again, markets follow themselves. So, how people generally, pursue things is very in line. It takes a lot for someone to break out and accept a much lower number, and those kinds of things. So people tend to hang on to these properties until they get what they want. That happens very often in real estate. Now, looking at this, we want to determine the values at T0, and I think when I copy and pasted this a bit, there was a little bit of a separation. I don't think I had this initial separation here, but that's fine. We'll just work over here. Looking at all these numbers, we want to know what it's worth today. So going to the math that we worked on previously, $25,000 in 1 year is 25,000 divided by parenthesis 1 plus this 7%, and we're going to hit F4. In the Mac world, you guys can just sort of type that in. We're putting dollar signs in because what we're going to say, and the reason we're doing that is as we're copying and pasting this formula, We're going to lock in the column and the row. See the N in the 163? That's column N, row 163. We're locking those in, and we're going to have an exponent here of 1 year. Okay. And what we're going to do with this is we're going to copy and paste, instead of retyping this formula every time, we're going to copy and paste it, but we're always going to refer to 7%. So what we don't want to happen is as I move down a cell or move down a row, what happens is Excel says, okay, this is 167. I'm down here now, it's 168. It would have moved this 163 to 164, which has no meaning in the model. So you're locking in saying always refer to 163 as you move the model around your files. You control return, and actually looking at this, the formatting is a bit off. So maybe it's good. We'll do the formatting too. I'm going to hit Control 1. I want accounting formatting. I want 1 decimal place. I want a $sign. The font is black, and I'm going to hit OK. And there you go. Okay. It's all that. We're going to copy. And I'm going to hit Control paste 2 more times, and I'm going to do this. I'm going to say Control 1. Control page up. I'm moving through the tabs, then we're going to tab through to the symbol and just hit none. Okay, so again, you can use the mouse to do it, but there's some keystrokes that you can figure out as time is going. I'm not here to have you memorize every single keystroke and things of that nature. You'll figure it out as you go along, how to do things quicker and faster, and instead of using the mouse all the time, that kind of a thing. You'll figure that out as you go along. But 25,000 2 years out is worth 21,000 today, and 25,000 3 years out is worth 20,000 today. So what happens is, if you take 20,000 and it grows at 7% for over 3 years, it'll become 25,000. If you take 21,836 times 1 plus 7% over 2 years, it'll grow to 25,000. You take 23,364 over 1 year, it'll grow to 25,000 at 7%. That's what we're really saying with this. And again, it's all about giving up this opportunity or that opportunity. It's all about that kind of thinking. Okay, that's what the time value is. Now the big one here, basically it's this, right? And what I can do is I can say Control D. It brings the formatting down. It brings everything down. And what this does for us, it says, okay, I'm going to get 450,000 in 3 years. Today, that's worth $367,334. So what that means is if I just took that amount of money, this right here, invested it for 3 years at 7%, I would hope to have 450,000. So I forwent that financial instrument opportunity, invested in the real estate or invested in some kind of special project somewhere, that kind of thinking. And if you notice up here, it says value at T0. You have all of these cash flows now that are valued back at time 0. Okay, that's really what that is. Now, there's a couple things you could do from here on out. There's a couple places here. I could see it says PV for present value. I can say equals sum, and we can just add up all your anticipated. This is what you anticipate getting, not what you're going to put out. So all those cash flows added up today would be worth $432,000. So what that means is you're anticipating getting 25,000 and 450,000. You're anticipating this series of cash flows. The value of that at 7% is $432,000. If you can come in at 375,000, obviously that's better. In class, I would stop and ask people, say, hey, is this better or not at 375? And I would be surprised that I would get a lot of silence and a lot of pauses in the answer to that question, because people just either maybe it was too complicated. The way I explained it was maybe too complicated, or maybe didn't read the chapter or something. But that was something that sort of moved people a bit, that they weren't really sure as to which of those was better and why. What we're saying is you're anticipating these nominal cash flows. I've done a time value of those at today at 7%. That value is $432,941. If you can come in at 375, you're coming in at about 50,000 less than it's worth. So that's good. Okay, so that's certainly a way to look at it. This other version here, this is sort of the NGIT version, and I'll do it very quickly. This is present value, not net present value. The difference between present value and net present value is the following. Net present value includes what you initially come in at. If you come in at 375, you come in at something like that. That's what that, that's what that means. That's what net present value means. You're netting out, meaning what you come in with versus what you're going out with. Present value is just simply your future cash flows after today type of a computation. What I'm going to do is say equals, and there's a couple ways you could do this. We have the 25,000 here, and we have a bunch of them, and we're going to use this. We're going to use the annuity present value formula, which is 1 over R minus 1 over N163 divided by 1 plus N163, and we'll have an exponent of this of 3 years. which is right there. That's the third year of this thing. That, if you go back to chapter, I think of the chapter, I think the time value of money, chapter 5, and that's another chapter, so it's in the bond chapter, which chapter 6. That's in there, where it's a summation formula of a bunch of payments, a bunch of series of payments in the future. We could just say 25,000 over 1 plus r to the first power, 25,000 over 1 plus r to the second power, 25,000 over 1 plus r to the third. We could do that too, okay, and that would work. But these are all uniform, and this formula sort of eliminates that enormous amount of typing that you need to do all that. And then plus, and here's something you should recognize from what I just described, you're going to take the 450 divided by 1 plus n 163, and this is to the third power, which is right there. Okay, so you've accounted for all of your cash flows in the future and your control return, and what you're happy about is you have the same number. All right, these two numbers match. You did this in pieces, this one, and this you just sort of did it all in one line. A third version of this is using the Excel function. I'm going to say equals negative present value parenthesis. The rate is, and if you look at how this sort of displays itself, rate, periods, payments, future value, and then type. What you're going to do is you have to plug it. It does all the math that I just showed you. It just does it for you just by saying PV, which to me is not very a useful thing to really know. But you know, it's all over the textbooks, and the CFA exam has a similar thing where you have to use a financial calculator that sort of operates like this. So learning sort of how to just plug in into a pre-existing algorithm, it might be useful. It's 7%. The whole project's 3 years. Now you do have 3 years of payments that are 25, and you have an exit payment of 450. Now you have to be mindful of directions. If you can see here, I put a negative in between the equal sign and the PV. The negative means that if you just plugged in the 25 and the 450, Excel would give back to you a negative number, meaning that you have to pay in at that. And I'm gonna break the mystery here. It's going to be 432,941, but I put a negative to sort of match how we've been delineating those numbers is the value today. I mean, if you said to someone, hey, this has a negative value, that would, you know, most everyday people who aren't really trained in finance or accounting, you know, like we all are, would get nervous and say, you know, why is it a negative valuation? I was trying to keep those positive just for sort of psychological reasons. But if you look at how we constructed all this, this is just, you're plugging into a pre-existing algorithm in Excel where you take the rate, the number of years, the 3 payments, and yeah, but you have to know what it's doing. Okay, there's an NPV function, there's a PV function, there's an IRR, there's a lot of these different things sort of floating around. So it's in your best interest to really understand the math from the basic algebraic, you know, functions and the basic operations of algebra and mathematics, instead of just running to some Excel thing or running to a statistical thing. When I teach probability and statistics, we're always computing everything ourselves. I think that's just the better way to go. To me, Excel is a fast, neat way to do math. I don't really use their functions often. I'm just displaying this in, just because it's class. I just want to show you guys that it exists out there. But certainly, you always want to be able to figure this stuff out for yourself. So we have 3 different ways of getting the exact same number, which is good. And the folks who've taken me in class know my violin story here. That I was the only economist at the private equity firm that I worked for a number of years. I had to check everything myself, and it was every time I wanted to hire somebody, they never wanted to do it. And, you know, well, we need an accountant. We don't really need an economist, and you know the top outside contractor was an attorney. They were constantly hiring attorneys for this and that, and that's what directed me to up my legal education dramatically, because I saw how important it really, and that's where practical education helps you. When these deals come together, sure, there's a math part, there's an analyst part, but certainly understanding the legal aspect of everything is critically important. Okay? It's critically important. So now what we're doing is we're taking the amount of money we're coming in with plus the present value. Okay, and there's your net. So there's your net present value, and this is what that means. That means that if you came in at 375,000, you're about $58,000 below what that product is worth. That's what that means. NPV being positive. So it means you're adding to your wealth, and beyond adding to your wealth. This is, again, it's not an accounting computation, it's a finance computation. It's not 57,000, 58,000. That's not your profits. It's not. Okay, you could sit down nominally, and actually we'll do that next to figure what your nominal profit would be, you know, type of a thing. Folks, you could go in circles with, you know, this analysis, that analysis, nominal, not nominal, inflation adjusted, not inflation adjusted. You can go crazy with all that stuff. But the net present value, the classic net is this, where you take the time value of all your payments and you take what you come in with. And with this thing, you're 57,009. And so effectively, the finance profit is that. But you're anticipating making 7%. And like I said, you can have all sorts of arguments about what we're doing here and why and this and that. And here, there's always somebody that wants to do a nominal computation. I'll just sort of jam it in down here. Equal sum of just all of these. In your pocket, right? 150. That's the in your pocket in your pocket profit. I have a guy in class who's always saying that phrase to me. What's in your pocket? That's in your pocket is $150,000 is what you're looking at, just nominally, not worrying about time, not opportunities and all this economic stuff that we think about. Just what's in there. It's 150, okay, which is what that is. So now we're going to spend $375,000 to construct this office block. We're going to make 150. Now, if you look at this, if you do a ratio of the profits, and we could just do the math on the side here, you would take that 150 for profit margin, that 150 divided by what you came in with, right? So you'll get about a 40% profit, which ain't bad. Okay, just the total. That's a total profit. That's not the annualized number or anything along those lines. We could annualize it. I could just very quickly show you how to annualize that number. What you would do is that you're going to get, now you're going to get the 150, and see, this is where it depends on the number of years and things of that nature. How do we do this? Okay, it'd be equal 1 plus the 40% exponent. It's 3 years plus -1. Yeah, but you're getting 11% a year, about 12% a year, if you annualize that. So what that means, the check on that is as follows. You would take equals 1 plus this number, the third minus 1, and there's your 40% back again. Okay, so how'd we do that? We took 1 plus 40% equals 1 plus the annual rate to the third power, and then just solved for the annualized rate. That's all we really did with that. I'm going to sort of just jam in the math down here at the bottom somewhere. It'd be, here, let's make this text. The little r is the annualized rate, and this would be to the superscript. That's the third power. And you solve for the little r is what you do. So the total return is the capital R, the little r is the annual return. And how you would do this is, let's see, and you always have to be careful. Whenever you have a superscript, you have to put a comma in and just give it a space in there, because you don't want everything to be typed to be the rest of the superscript, which can happen sometimes. It's 1 plus r, and we're going to go to the third power with this. 1 divided by 3. Get rid of the superscript, then plus a -1. Okay, that equaled the annual rate. Okay, now a little bit of math, a little bit of mathematics, never bad for us. Exponential math. Okay, so that's pretty much that. R is the total rate over the 3 years. So we solve for that. So you're making about 12% a year. Like I said, I just threw some of that math in there and let you guys just mess. I should have moved that to a better spot somewhere, folks. All of these types of models, I'm always making it better, always improving, always making changes. So it's never done. It's what I lectured on a couple decades ago, and now we're always making it better and making it electronic and all those kinds of things. Like I said, you never want to lose sight of what exactly you're doing. It's a real estate project. You're getting cash flows, and you're trying to figure out. You're trying to figure out those cash flows and if it's profitable for you to engage in that or not. That's just a summation. The 150 is right there. The 40% is just the ratio of 150 over, the profit over what you're coming in with is for 40% profit over 3 years. Then you annualize that number. The Bureau of Economic Analysis does this stuff all the time. Okay, so you have that. The general NPV for this, again, that's for this particular model, because you see how there's 2 3-year pieces here. Your initial investment, first-year cash flow, second-year cash flow, and then 2 third-year cash flows. That's the net present. That's the formula. Okay, and now, we have R up here, And we're going to back out solving for R as another part of this problem, and we're going to do that relatively soon. But here, there's something else happening here. Yeah, 375,000 your own money. Most buildings have at least a year. Okay. So, yeah, this is the same situation. So this is the 375, which is right there. Okay, you have that. Now, we've looked at this. So that's the initial investment. And again, it's negative for, and you have to realize everything's a bilateral. There's always two parties or multiple parties with transactions. Things don't just go one way. You talk to academics, they think of everything as a one-way street, which is a little dangerous. There's 1,000 shareholders in this project. So instead of somebody raising that money by themselves, we want to go to the guy, the plumbing guy, the construction guy, and if they all put in some money, they'll all profit from this project. And that happens too. There's some, when you're a contractor or a landscaping, I've met people who are landscaping guys who are involved in all sorts of finance, all sorts of things. You're around these environments all the time, and you have your ear to the ground, and it something that may not get to the front page of the Wall Street Journal type of a thing. You may have some insight into something, some kind of good opportunity out there. You've been around long enough and you've seen different things happen. So we have 1,000 shareholders now. So each person has 1,000th of the profits, and also only makes 1,000th of the initial investment, kind of a thing. So if you do that math, and actually it's funny, I didn't do that math, but we're going to do it right now. That is equal to this divided by that. So everybody's investing $375, per investor, type thing. Right, per investor. Okay, so you have that situation. That's your per investor number. And also that investors getting a part of the profits also get divided by 1,000. So this is why when you do an analysis of a stock and those kinds of things, people care a lot about, if the shares are going to be diluted, because the earnings get spread over more people. And if you're one of those initial shareholders and all of a sudden there's another 1,000 people or another million people or something, if the big stocks, that's a big deal. Okay, and companies are always trying to buy back shares because they want to avoid that dilution issue and have be more valuable to the shareholders that exist. Have them have more of the earnings type thing come in. It's very, very important. So now looking at this, we sort of did a little bit more math here, and I did this per shareholder now. And if you look at this, the price per share, I really, really, really. Now I'm looking at how I broke this down. It says price per share on that. That's the present values is really what that is. It's saying price per share. All right, let's go with that and let's see sort of where it takes. But you see, you're getting the 450,000, you're getting the $325,000 cash flows. Yeah, I mean 7%, sure. Okay, right, because that's not saying what you're coming in with. That's just saying what you should come in with at expecting a 7% return. See, that's the second part of this, expecting the annual return. That's where the finance piece of this sort of comes in. Okay, so you're looking at that, and we're going to click here. I have an arrow here. I'll explain why I have this and what's going on here in a little bit. This is a numerical method for really backing out. If you come in solid with 375, or you're coming in with some kind of number, what are you really? It's not 7%. I mean, it could be, but what are you really returning? Type of a situation. So we're going to compute this whole model that we just saw up here, but we're going to compute it per shareholder. So that means everything, all the claims are divided by 1,000. And folks, as I'm not reading these sort of verbatim, but certainly just go through all these little text boxes here, and you can just read through and understand what exactly is going on here. That should explain everything too. So looking at this, and again, let's clear out everything here, which is right there. How did I do this? I did this by taking, we took the initial, so again, we took that initial model and divided everything by 1,000. So we're coming in here, equals this divided by 1,000, F4. Okay, that's 375. You're coming in with all these 25s divided by 1,000 again. hit and you just type in those dollar signs. What you're doing is you're saying, okay, I'm going to take the cash flow, the whole cash flow, the whole project up here, divided by 1,000 shareholders, and what if one shareholder going to get 25, and then I can just fill it down like that. And now I don't see if I just filled it. You might wonder why I didn't fill down one more. I have a little sort of comment. See these little red triangles in the corner, in the upper right corner, the northeast corner there. Is this forecast sale price of the building? If I just filled it down one more level, it would have overwritten that. I've had to retype that comment. So what I'm going to do is I'm going to say copy, and I'm going to say Alt H V formula, and then hit escape. We're just going to bring the formula down. So I didn't mess with the formatting, and it's already formatting and accounting and those kinds of numbers. And I think all of these are relatively transparent to you, and you know what we did here. We just took all the cash flow from the whole project and just divided by all the shareholders. Now we're going to go through the same steps and procedures as we just worked on. So we're going to find that the specific time value, and what it's really going to be is it's going to be all the numbers just divided by 1,000 is really what, compared to the numbers up here. I could just redivide these. We'll go through the steps, which I think is an important thing. Once again, you want to take the 25 today divided by 1 plus 7% at 4. And you're at 1, which is right there. Okay. So you're there. So again, for every guy who comes in with whatever he comes in with, $375, he'll get $23 in a year, and they'll say copy. Actually, we can do for all of them. Alt H V formula. Yeah, there they are. Okay, this is what those cash flows are worth today to a guy who came with $375, as opposed to $500,000, $250,000, that kind of a thing. And then you do the same maneuvers. You just sort of add these all up, right? You just add them up. And I like this way better, right? Now it's 432. Up here is 432,941 type of a thing. Okay. Over here, actually, I didn't do it using Excel. I'm gonna just drop it in there. Drop that. Whoops. Right in there. And now we got to fix all this. This is the percentage, right? Rate, years, annual flow, and then the 450. Yeah, there it is, 432.9, $433, $433, that kind of number. And then in here, and let's do this sort of differently. Let's do this as, we'll say parenthesis. This is 25 multiplied by all these pieces here, 1 divided by 1 plus the rate, and we'll do this rate a couple different ways. This is after 1 year. Actually, here, this is what I'm going to do to sort of avoid a lot of typing. We're going to come in here, since we know we're going to repeat the sequence with just very small changes. We're going to say plus, I copy and paste it, plus, copy and paste it, and then plus the last one. Okay. This, and actually, whoops, this last one we don't need because it's not times the 25. So there's only 3 of them in there. This would be 203, right? And this would be 204. The exponents are changing, see? Right? First year, second year, third year, and the 7% is the same the whole way. Okay. And then we're going to go to the end. We'll say plus parenthesis. You're getting the 450 divided by parenthesis 1 plus L197, and then here's this. Okay. And there you go. There's your 432.94 again. Which is that. Okay. There's all your present values. That's what this thing is worth. Now, what you come in at is a different story. Okay, you're gonna come here, and we're gonna do the same sort of maneuver. I don't know what I'm looking. I don't know why I didn't do the. Did we do this with MPV? Yeah, we did this with the formula, right? Using Excel. I don't know why I don't have it in here, but this is using Excel. Okay. I don't know why I didn't put it in there, but I put it in there now. Okay. Again, this is relatively fresh. These models. So I'm making these videos, but who knows how we're going to change this at some point. I'm making this because I have the course coming up. I have the the online course coming up pretty soon. So we want to get these out the door. But I just sort of made these notes. So there's always going to be change, and we thought to do this better. And that's what I love about what I'm doing, that we make those kinds of changes. Now, the net present value is what you come in at, what you actually come in at in nominal dollars plus the present value of all your cash flows. So once again, it's a similar number, that 57, instead of 57,000, it's $57.94. So you're adding. So again, if you're investing, 300 something dollars, you're coming with 57. Your wealth is going to be added to about $57. That's pretty good. Okay. So, and once again, we can do the same. We can do the nominal computation that we just did. Equal sum parenthesis. There's the nominal computation. 150 per person. So they come in with 375. They're going to make 150. And again, we'll look at the rate of, this is the same, this is all the same stuff from before. I just want the formatting down all page. Let's see, return. So this equals the 150 that you're going to make divided by negative, right there, 40%. Total return is 40%. Okay, total 3-year return is 40%. Which is that. And then we could, break it. We can annualize this, and we just did it. Edit. This is annualized over 3 years, which is right there. Okay. This is going to be equal to parenthesis 1 plus one right next to it. Exponent 1 divided by the 3 up there for 3 years, and then plus a negative 1. There you go. That's per year what you would be earning. You're talking about 12% a year with this, which is certainly better than the 7% that you thought that you'd be doing. And like I said, there's all sorts of angles we can take on this. There's a lot of stuff that we can look at here. Okay, and again, I'm looking. I don't know why I didn't do it, but I know there's a function here equals NPV, right? And the rate is here. And there's the rate, comma, that value, comma, this value, comma. Then the sum of the next two. Right. And you're going to click up there, put a parenthesis, close that up, and then plus. Yeah, you have to be careful with what you click on. Comma. This, no, not that one. Comma. Green, the purple. Yeah, comma, sum parenthesis. These two. Right. Close that, plus this one. Sometimes it, yeah. Whoops, what happened there? This. Oh, we have 2 commas there. Fine. There it is. Okay. Yeah. Again, I apologize. I don't know why that's not sitting there. It should be sitting there. Yeah, we didn't even work that up here. So yeah, I'm sorry. Let's get back up here for a second. This equals what you came in with plus NPV parenthesis the rate 7%, comma the first cash flow, comma the second cash flow, comma the sum of the next 2, close and then close. There you go. Right, that's using the NPV function. So yeah, now we did it in both places. Did I do it? Yeah, I did it up there. Okay. Yeah. So now I'm just gonna pull down the comment and all that stuff. We'll just drop it in over here. What it looks like. Yeah, this is just this. There we go. Okay. Well, that's what that looks like. The initial amount, the rate, and then the 3 cash flows. And you had to combine the 25 and the 450 because they occurred at the same time, type of a thing. Okay. But there you go. All right. That's all of it. Okay, so that's per share. And now what you do, to sell to, this is, to sell the project to outside investors, kind of a thinking here. We came to this thing, we multiplied all the shares. So, so we took equals the 1,000 shareholders times. We're just going in circles now, kind of. Our present, any of the present values, right, which is right there. I make this a little bit bigger so you can see the numbers there. So what this is worth, 432,000. And again, if people come in with, let's see how we came in with this. Yeah. Now, right. If people come in with a negative version of that plus the cash flows, which is this thing, right? It should be worth that, right? It should be worth about $50,000 on a $375,000 investment, which is pretty good. That's not bad. It's not bad. And which again, we're probably going to get the total thing is going to be 40% again. And let's just check it just to make sure. So equal this thing divided by what you came in with. Yeah. Actually, that's 15. It's about 15 is what that is. Because that's a little bit higher than what we had before. Okay. And like I said, so you got to keep everything straight as to, what you're taking for these percentages of and all those kinds of things. So like I said, you got to be very cautious and careful with that. Another piece of this, actually, I'm just going to look here for a minute if you guys don't mind. Yeah. So yeah, we did this using a couple different profiles here. Yeah, these formulas, the 12.6 and all that. Yeah, these are the IRR computations there, and there's a couple of them that are sort of happening here. And yeah, we wanted to determine all that. So yeah, that's that one. Let's just give me a second. I'm always sort of remembering why we do what we did here. Yeah, that's that. Okay. So yeah, I made a couple of these. Oops. Yeah, I use for some reason, I don't know why, but on this curve, usually you click on the numbers here and you can sort of see what's going on. But yeah, let's do it like this. Select data. There's the initial edit. And what is this? This is K242J is right there. Okay, that we have. Okay, it's all well and good. And then the revised one, edit. This is K and this is L. Okay, so it's all here. Yeah, folks, usually I could just click on this. You could just see sort of what's going on. But that didn't, for whatever reason. I think I actually used formulas from the Excel where there's a polynomial that comes through this. That we really don't know what the equation is. And actually, just looking back at this for a second, let me just make this a little bit bigger for you guys. Let's see. We can show the polynomial. Let's say here we do polynomial. Yeah, display equation. So yeah, there it is. Okay, there's that equation for that one. And trend line here, display equation. Yeah. Okay, so there's the equation. It's an x squared version of this. And I'll tell you, if I dug into the numerical method of how to get those scalars, get the multipliers to this, we probably could do it. So I just have to dig into the math book to get it. But we probably could do that. And actually, that'd probably be a really good exercise. After we shut the video down, I can do that. But we're showing you the equations here. And actually, I'm just going to drag this. Whoops. I can drag this. Yeah, I can drag the equation around a little bit on me. Yeah. That's so you can see what that is. So that's 302,867 x squared. That is a part of an equation that goes through those points a little bit better, than just putting a straight line through them or just sort of connecting the dots, so to speak. I have to dig into numerical methods book to do that. But yeah, I like that. And here let's look at the R. And they also had an R squared version of that. So like I said, when you pick, see, you can pick, and Excel does it for you type of thing. And we're going to do display the R squared. which tells you how much of this is sort of, how much of the variation is explained by the model, not explained by the model. I have that in the in the stock analysis piece of this. Yeah, there's the stock valuation right there. So your stock valuation right here, and let's quickly go to the. I want to give you guys the actual definition for the R squared. What does it say? It says, yeah, actually, yes. So the R squared is the fraction of variance that is accounted for in the model, and if it's 99%, that's pretty good. Most of the variation in the models is explained by that. You don't see that good of an R squared a lot of the time. This is just this is 2 times. This is like 2 million. This is a million. Those kinds of numbers, because these are in the hundreds of thousands, and anything to the 6th power is 10 to the 6th power, which is 60. So it's 2 million, 1 million, those kind of. Like I said, that's at another time. I think it'd be good to really hammer in there and at least be able to do get some polynomials, and you have segments of those curves that'll tell your story for you using some mathematics, okay, which is generally going to be a pretty nice thing. And like I said, then you can just click on this one last time here, which is format the trend line. Like I said, this is really doing the heavy duty math and your moving average. Like I said, you should spend some time in your life and really really get to know how to do that, because there's not a lot of people that know how to do it. And it's very this is 100% of the variation that is explained by that R squared. That's a statistical term, and it involves correlation. The statistics are very. Let me tell you something, folks. You spend some time with the statistics section, you learn a lot of things. Okay, so very useful for you guys. Yeah, that's all I'm looking at. It's all. So if we move this around, it's all sort of one thing, which I like. I don't know if I should just scrunch that in here. How's this going to look? I should bring it in there like that. Yeah, that'll work. And this guy is in there. It's the blue one. Okay, that'll work. Okay, we're gonna leave those in there, for now. Like I said, we're always adding to this. Like I said, this is a fresh. These are all fresh cuts in here, in a sense. So, there's a lot of things that we're dealing with here that are useful. All right. All right. Now, like I said, let's get back to we could do some equations here, but let's get back to the numerical methods work, which is the next thing on our plate to deal with here. So, okay. All right. So we're there. We're here. Okay. Yeah. So getting back to the finance, like I said, I can get deterred pretty easily with stuff, but getting back to the finance pieces. Now I've got to look on the bookshelf and see if I can find a numerical methods book that'll tell us all that. Okay. Now you have to be careful with the next thing that we're going to do. We kept taking these, sort of profit margin computations, what you came in with and what the net present value is and the net gain, those kinds of things, and determining percentages. But there's a real annualized percent, and it's not that the 7% is a comparable, which means that we've identified another project that we can come in and make 7% a year, and we're foregoing that to do this one. How far away are we from the 7%? If you're positive with your MTV, that means that dollar-wise you're in good shape. That means this is going to do better, and that's all it tells you. You're doing better, but it doesn't tell you how much better percentage-wise. It tells you how much better dollar-wise, but not how much better percentage-wise. Because still, if MPV was 0, that means you picked the discount rate exactly, and all those cash flows are your return. You're making that 7%. If MPV is 0, when it's above 0, you're doing better than 7%. And what you have to think about is the following. I'm going to go back to this initial equation. And I'll tell you, this is why I do what I do for a living, because I really do think about these things very deeply. Look at this equation. And something's going to happen sort of with the curve that's going to be a little paradoxical. Your return is going to decline as MPV gets more positive. And you might say, wait a second, how is it possible? Or is there something wrong with that? Folks, you have to distinguish between the economic meaning of something and the mathematical meaning of something. Mathematics sort of has its own ends and its own interpretations and its own everything. It may not always coincide with the economic meaning or the reality meaning of something. So here's what you need to keep in mind. As your C0 as you decrease what you're coming in with, okay, this all becomes more positive. Okay, so the NPV should increase, and that makes sense. That makes economic sense, it makes financial sense, it makes accounting sense. Now, as R moves around, okay, as R gets a little bit smaller, the impact of the C1, C2, C3, the numerator becomes more powerful, and the more powerful force in the equation. It becomes more positive. This goes out, it becomes more positive. That's how you get an increasing NPV as R decreases. Now, the reverse of this is as R gets bigger, these numbers become smaller, and the negative can sort of take over the dominance of the equation a bit. But like I said, all the equation that we're going to graph right now, in terms of meaning, all it's going to have for you in terms of meaning is it's going to show you where NPV is 0. It's going to show you the point where your actual rate of return is that may or may not be 7%. It's not a scenario curve where, oh, if you invest this much, you get this return. It's not that. Okay, so you just got to keep in mind, it's not a scenario curve. It's just the usefulness of the curve is the one point where where NPV is 0. That's the usefulness of what we're going to do next. Okay, so now looking at this, if we just fill in, all these cash flows, we're going to have this equation. And actually, probably what I should have done is type this equation out for you guys here. Let me see if I can just sort of jam it in somewhere. It's here. It's sort of here, but yeah, all right, we'll just put it right there. And what are we coming in with here? This is what? Yeah, so we're going up to that one. So this is going to be, yeah, if you just look at these, it's just these. Okay, it's just that, but we'll put the numbers in. If you want to really see what numbers, we can put the numbers in. So this is going to be negative 375.123.0, and these are all 25s, right? This is 25. Here, actually, we can do, instead of just struggling to retype that all the time, you can just keep dropping it in here. Dropping it in here. Dropping it in here. And this is 450. Right? There's the equation that you're going to be dealing with. Bigger, yeah. Okay. There it is. Okay. This is negative. Okay, you got, or I should have put parentheses around that 375 in here. Let's give this a little bit of, oops, make it negative, give a little bit of space. Yeah, a little bit more space there. You can see that's a negative number, or put parentheses. That's what you're going to be dealing with in terms of, if you want to solve for R and you want to determine when NPV is 0. That's what you're dealing with that long of an equation. So I'll just sort of let that sit for a minute. Okay, which is right there. Okay, now you're just going to try a bunch of rates. Here's 0%, and this is all pre-formatted, and we're going to do this plus 1%. All right, I'm just going to go down to, I don't know what number. And this is, I don't know, I typed this in as a 50 for some reason. I'm sure after working on this, I'm sure the reason will come to us as to why we did this. All right, which is right there. Okay. So you have all that. So you just added a percent every time. You don't need 2 decimal places for any of these. I don't know why these are in 2 decimal places. You're just in 1, right? Because you're not going to have that much of a variable. And we'll expand that as we go along. Okay. We can use the Excel function or just program this in. Let's now you have to do some significant programming here with this. That's for sure. And it's this stuff. It's this stuff down here. This one. It's something like this that you're going to work on. Right. This thing. Right. It's that you're going to do. And then you added the money that you came in with. You added that number. So, okay, you're gonna come back up here. Equals parenthesis negative 275 plus parenthesis. You gotta be careful that the stuff doesn't sort of go south on you. I don't know why, but it's here. And you should probably lock those. And this is 1 divided by. Now, the rates that you're going to be using are the ones right next to it. Okay, are right in there. So it's K222 minus 1 divided by K222, row and column, times 1 divided by 1 plus K222. 3 years. you're going to anchor that, and actually you want to anchor all that initial stuff. You want to anchor that thing. You want to anchor that thing. Okay. Everything's anchored. Okay, you have all those. Did I get everything? No. And I do the 450 at the end. 450 at the end. 50, which is right there. Anchor that guy. Divided by parenthesis 1 plus K222, and this is K169. Anchor that, and then that's it. Yeah, you don't need another parenthesis on. Oh, you could. It's just to give yourself some sanity here. You could do that one. You could do that one. Okay. There. Now you get a division by 0, but don't worry about it. Yeah, but you don't need that. Control 1, get rid of the dollar sign. None. There you go. Okay, so what it's saying is if you're anticipating 1% return, which is not a very significant return at all, it makes sense that you're looking at a big NPV, which means if you're in Japan and you can just get 1% on your money, you're looking at this. It's a good project to get in on something like this. This one is 2%. All right, 121. And like I said, you go all the way down. So what you're doing is you just go through even up to just 10%, right? It's showing you now as you're foregoing bigger and bigger projects, your NPV is getting smaller because you could make it someplace else, and you're foregoing that to get involved in your project where it has a fixed sort of threshold to come into it. What you care about is based on the numbers that your entry point in terms of an investment. You want to keep going with this until you find your 0. Now, actually, if you just look at what just happened here, when you went from 12% to 13%. Went from 5,000 NPV to a negative 4,000, or a negative 4,000 NPV. So right in here, the zeros in there someplace, right? Like I said, so the math, the math that helps you is never bad. It's always a good thing to have the mathematics that helps you out a lot. Okay. So you've narrowed this down a bit. And actually, this for some reason, like I said, I guess it'll come to us at some point. I went all the way to 50% for some, just to see what the numbers would look like, and I guess there was a reason why I did that. But the thing to focus on is this, where you formulated this very complicated equation in Excel, that your net present value equation in Excel, and you tested all these rates to figure out when I was going to get net present value of 0. Which means what's my actual returns? And I had mentioned to you before, get ready for your return to be better than 7%, right? Because your NPV is positive. So at some point in between 12 and 13%, NPV is going to be 0, which means you've anticipated the correct return, and that's a return that you should expect. Okay, but still, nominally, you still have an earning. Okay, and again, 150 or 150,000, whatever it may be, you're still going to have that. Okay, but so. That doesn't change, but it's just your analysis of this, and the JP Morgans of the world and all these places, they love this type of stuff. Okay, they love these kinds of analysis. Okay, so but we have a way to go still. It says at what rate is NPV 0? Okay, we're saying that. Now the next thing you're going to do is you're going to say equals the 12%, which is right there. And now I'm not going to move by 1%. I'm not going to move 1%, 2%, that kind of a thing. What I'm going to move is by 1/10 of a percent. So I'm going to go between 12 and 13%, but I want 10 of them. So this is where your good physics background comes in. You could do this. You could do it like that. All right. You have 10 choices between 12% and 13%. And out of here, you could bump that up a bit. Whoops. To 2 decimal places. You could do that. We didn't use it says using Excel. We just programmed it is what we did. So again, I'll say it again. These all move by a percent. So if you just look at them, it's the previous percentage plus 1%. See how I did that? Okay, just so you guys can see how that worked. Down here, right? It's just the previous entry plus again, it's going to be formatting percentages, that kind of a thing. This is just the NPV, which is this formula, which minus 375,000. Here's your 25, which is right there. And again, what we did here is the numbers or the math looks a little bit different. I use the summation formula for this. Just use this and don't worry, oh, it looks different. If you go back to chapter 5 in the time value, you'll see there's a whole discussion, but we're just using these formulas. So just be comfortable with that, and then plus the 450 that comes in 3 years down the road. Okay, so you have all that. All right, so like I said, so when it's switched, NPV goes from 5,000 to minus 4,000. You're in there, and now you're going to do the same procedure again, and now you can just copy and paste all this. Okay, and like I said, I think you blew out a wall just now when you did that. But like I said, let's fix the border. It's a right border, but we've got to change the color. Once we blue. Okay, whoops, I don't want that. Let's see. Oh, I want the right border right there. Yeah, there it is. So you have to be careful you don't blow your walls out. And what we did was I changed the border color a bit. Okay, so it's this. It's the same formula, but just now we're testing from 12 to 13% by tenths of a percent. And once again, if you're in class, I'd stop and say, hey, who can determine, what this is, type of a thing. I'd ask that question. But here's all borders, yeah. Okay, which is right in there. Okay, there's your borders in there. So it's in here. You bold these out. So now you're between 12.5 and 12.6, and you see your numbers are a little small. Instead of thousands, it's 583, 359, and now you do this procedure one more time. You say equals 12.5%, which is right there. You take these two, copy, you just drop them in here, paste, okay. HHN, and now you're going to go, instead of going by 1 over 10, a tenth of a percent, it's 100th of a percent. So it's equal to this thing plus 1 divided by 100th of a percentage. And you're going to say, actually, all these are in there. And we're going to say copy, and we'll just do formulas, all HDF. Okay, now we sort of gave away the answer a bit. Obviously, as we do this, this work, whoops. Shift down arrow, Control D. All right, copy. You're going to paste all into there, paste, and then here just copy. This is just the formula Alt HDF. Okay. And actually, what I just did was copy. I come up here, paste formula. That's it, and just paste formula. And again, you're going to pick this, even though forgetting about negatives and positives, you're going to pick just a small deviation from the actual percentage that's going to give a 0. We're settling for this. This is not NASA. We're not launching space shuttles or anything. So we'll pick 12.56%. Okay, but welcome to numerical methods. That's about all I can tell you with that. But that's about what this was. Okay, so we did a numerical method with this, is what we did. So yeah, and it's looking. I'm just looking at what we did here. Pretty good, 206. Yeah, because I have another version of this sort of floating around here, because we changed that we changed the input number. We had a revised version and an initial version. Yeah, this other one here. This is the initial version, because if you look at what we did here, this was the 375 is what that was. Okay, so the other version of this, and what I probably should put here, we're going to cut this a bit. You can see it. This is, we'll say home, Control 1, subscript. This is revised. Okay, that's the revised version. And I think that's what I called it here, if I'm right. Yeah, revised is the blue. Yeah, 12.6. And then the initial was the red, and a little bit of a higher number. So we're going to come. And like I said, I apologize. I should have had these. And like I said, this is a fresh cut, is what this is. This is. You're always making it better, and we're to stick the equation, a better version of it. That's the initial. And then you're going to come in here, and this is, I think, 350. I hope. Is that what that was? Yeah, came in 350. And we're going to recycle through that also, is what we're going to do. And actually, we figured it, I think, up top, because it's just a 1 year hold kind of a thing. So we didn't need to do this whole numerical method piece. So all I did here was, and I'll do it here. I came. Yeah, I came over here, and I could even just do this, say copy, paste. Uh, yeah, it's not even that. Yeah, look at what it is. It's not even that. Yeah, you're getting the money back in a year, so it's not even this. It's this. Right. You don't have all those 25,000 cash flows. Yeah, it's that, and actually this is just a year. Yeah, it's just a year you're getting it back. It's that. So like I said, folks, you got to understand your formulas. And here you just backed out the R is what you did here. So again, just to sort of solve for this, and we'll do it. We did it on a pop, but we'll just do it again. This equals yeah, and actually, and we're not getting 450, right? We're getting 400, right? Yeah, equals ratio 400 to 350. So it's 400 divided by 350, it's -1. That was the number. Okay. And you'll see that on the graph. Yeah. See, it's 14.29 right there. Yeah. So there you go. And like I said, the reason we did all this computation is um, the reason we computed all that stuff is because we have to have points to graph. And what is it? We have K 222, right? And this was just a year out. We're just going to we'll just use that one like that. That's it. Can that be 750? Man, something happened here. What happened here? We didn't make something negative, I think. Yeah, yeah, yeah. That 350's got to be negative because you're coming in with it. So see a little thing, a little something that's off, throws the whole thing in disarray. So it's negative. There it is. That's it. And the whole way down here, Control D. And somewhere again, you look in here, somewhere in there. And again, we know the number, right? We know it's 14, right? And this makes sense that it's between 14 and 15. So that this makes sense for us. So 14%, 14.29%, and that's 15%. Yellow this thing up a little bit, bold it, yellow border. Okay. So that's NPV initial is right there. Like I said, we can go through all them. We can go through this all again to get that number. But like I said, we didn't need a numerical method because we could just back it out, which is what we did here. Okay. There's a computer system one that's sort of sitting down there also that we're going to be able to deal with. Okay, we'll get to that. But yeah, let's make a graph is next. I want to make a graph of this thing. And like I said, I use the polynomials. Like I said, now I'm sort of engaged and excited to make this and have you guys in class figure out what these coefficients are. I don't want to spend a crazy amount of time on it, but let's just see very quickly. Numerical method. Yeah. Okay. I knew it was something like this. There's with bisection, but like I said, going through the whole secant method, so all of these things. Like I said, I have to dig into this and really, 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 spend the time. There's different versions of this, and through the algorithm. But yeah, all stuff that's sort of coming back to me as I'm looking at it. Yeah, Newton's method. Yeah, but Newton's method, but they just sort of left it sort of simmering here. All right, we'll spend some time on it at some point. That's a nice. It's a nice thing to know. Like I say, at least to get up to like an x squared or something along those lines. But there's a lot of stuff out there. Newton's method, folks. Jump on it. It was in the calculus book. I recall it in the calculus. Newton-Raphson method. Yeah, look at that. Great. It's great stuff. Okay, but we'll get back to that at another time. Like I said, we're not really prepared to. I don't like to do things I'm not really prepared to. Right now, we're gonna just make these make the graphs, and we'll call it a day with this particular problem because we're spending a lot of time on this, but it's in a good way. So, okay, I want to graph between. And how did I graph? I graphed between. Yeah, I did graph between 0. I didn't do 0. Yeah, I did. Yeah, because that shows. What does that show? When it's a 0% version of this. Oh, those are your profits. Yeah, that's your 50,000. Again, the economic meaning of things, right? Those are your profits, right? You came in at 350, you sold it 4, and we computed all the 50s on this one, right? That was the revised version of this. So it's good. It's good to start at 0 if you can. It's never a bad thing. And actually looking at this, and like I said, you guys have so much notes here. You have all this, like I said, the numerical method is here. We'll get to this sort of next kind of a thing. But so we'll try to keep it in nice little snippets. But yeah, here's the IRR. Here's the revised. Oh, okay. We did have all the equations here. Okay, there we go. Yeah, and actually, we've actually found a point of intersection too. We also did that, worked on that. Okay, so we did do a bit of thinking on this. This is some of the self tests here. So we worked around things a bit. So yeah, here's internal rate of return. We'll get to that sort of next. But like I said, let's knock out the graphs for these things and yeah, get this thing sort of moving in the direction that we want here. But yeah, we do have, this is the MPV for the revised equation. This is the initial equation. So yeah, folks, I have to apologize. I did sort of stick them in there. And then I set them equal to one another. So again, but how, and again, you're sitting there looking at it, how good your math is and how comfortable you are doing, this kind of mathematics. Is always an important, piece of the puzzle. Yes, again, how comfortable you are with your mathematics is always an important piece of the puzzle with this. So, but yeah, there you have the original equations, and nothing's mistyped or misspelled or anything. So, if this is the office block version of this, yeah, I have 2 of them for some reason. Let's just sort of jog my memory as to why there's 2 of them. It says initial graph in the other version. This, yeah, this was this one. Yeah, this is from the self-test. This is not ours. Like, at least we didn't work on this right now. Okay, that's self-test A2, and that's coming in a future video. You could bank on that coming. That's for sure. Yeah, the cash flow for year 3 changed a bit. Yeah, so we have a version of that. But this is the original version. Like I said, we'll use the polynomial sort of version of everything with this. Okay. So we're here. We have some equations. We have R squared. The variance that's described. All the pieces to the puzzle, are there. All right. Let's do the initial one where it's a $50,000 profit. Yeah. So there's J and K. Yeah, like I said, folks, I have to apologize. I have to dig into this a little bit every time I want to look at it. Yeah, J and K. Okay, let's make that graph. So again, how to make a graph? I'll try to take my time with it as best I can here. You're going to do, we can just take this, start with this. Let's see if I go to 20% with this. Yeah, I went up to 20. Okay. Yeah, and we'll do insert. We'll do scatter. scatter with markers. Yeah, to get the polynomial piece of it. So see how I did that? I'll do it one more time. You highlight your Y. That's always the best way to start. You can go to Insert, Scatter, and this is Scatter with Markers Only type thing. You click on your layout up there, your title, your axes, legend, top. Right, so we're on the way. This looks very, very vanilla, but we're on the way to something really, really good here. So take a mental picture of what this looks like now, and then what it's going to look like in a little bit. Grid lines, you want any horizontals on those. I don't like the diamonds. I'm right clicking on the diamonds. We're going to format the data series. Center. Make it 3. Okay, we don't need big markers on this. Okay, what do we call this? Internal rate of return office block. So you're going to come up here, Control A. Your second line can always be a bit smaller. It doesn't have to be, the same font size as the sort of the top line. It gives the top line a little bit of distinction, which we like, those kinds of things. Okay. So you click on these curves, and yeah, see how it highlights them? That's how it should work that way. When you highlight this, it shows those. Now, this is just versus a series of, we counted the points pretty much, but you want to have this versus the percentage, even though it pretty much matches up, but you want to have that as the percentage, match up towards the percentage. So go to Design, go select Data, you're going to go to Edit, you're going to click on this little select range for the X, and you're lining up, not the 50, but everything you have a Y coordinate with, you're going to line up the X coordinate for, and this is initial model. MPV initial. Hit OK. Okay, and it gives the color, all that. Let's mess with the color a bit. Have a little bit darker of a blue in there. All right. Outline. Outline. Now, actually, that's the line color, so we don't want to do that. Okay, but there you go. Discount rate. Down here, click a rate in percentages. Make sure you spell it. No typos in your graphs. Net present value United States dollars up here. Okay, see what that looks like, and you don't need multiple dollar sign, no multiple decimal places here or anything like that. You want to do a border. You want to do shadow right there, and you want to do a little bit of a nice light fill, very light fill, something like that. There you go. See, all of a sudden now looks like this belongs in the Wall Street Journal, right? And it looks pretty good. Okay, and now let's play with this. Let's do add a trend line. I think we did that before. Polynomial order 2. Display equation, display R squared. There you go. Okay. Again, I don't know if I can type in this. I may, but this is. Can I do an outline of this box? Let's see if we can. Oh yeah, we can outline. Yeah, good. See, right? We can outline. So it's the blue type thing. And actually, what we did here, this was IRR 12.56%. Right? Yeah. Oh wait, I'm sorry. This was. I mean, yeah, we our colors flipped a bit, but that's fine. Um, this was the initial. So yeah, this is the, we flipped the colors a bit. We had the initial as red. Here we have initials. Don't never do that, but we did it here. So actually, in here I want the fill in this box be white. All right, click in here, IRR. Make sure 50,000 with this. IRR is 14 point. What is it? 9. Okay. That's 14.29%. We can do a little bit more of these here. We can do major 5%, maybe do 2%, something like that. Yeah. Okay. And also the font here, you can change the font a bit to maybe, 9 or something like that. So those numbers get a little less, they're not jumping out as much at you. And we're going to make this a little bit bigger. See, we're just working on this right now, but this is going to be a little bit bigger. So, yeah, which is right in there. Okay, but there you go. Okay, there's your IRR. Yeah, 2.29%. Yeah, that's the initial. Okay, and like I said, I promise you, we'll do something where we determine those coefficients. I hate to put anything before you, and there's we didn't fill something in or questions. Like I said, I'm not really prepared to go over Newton's method or the Newton-Raphson method or something like that. But I have numerical methods books sitting around, so I'll dig into those a bit and see what I can figure out from them. Okay, or the internet, because when I was in the math department, the internet was as prolific as it is today. But yeah, so here's polynomial order 2, and that there's we used Excel to determine that equation, and we'll sort of stay with that. Okay, but the initial version of this was the revised, right? So this is MPV file revised, and we'll do this to this, which is right there, and we'll do that. Okay, and there may be some, there may be a bit of a problem here because we didn't do the let's hit OK. And okay. Let's get rid of this stuff. The marker, make it look smaller, so we can see what we're doing. And marker fill, solid. We'll do a red, nice red. Okay. And if you notice, there's a little bit of the outline is still blue. So fill shape outline is still red. No, we don't want that. Okay, it's still blue? No, it's okay, they're red. Okay. This one. This came there. Yeah, that's the R, and we're going to fit the next line in pretty soon. Yeah, we got to be careful with this now. We got to go back in here. It's 0. Let's see. Let's just see how this is. Whoops. Let's just see how this is going to work. Copy. Is it 0? Yeah, actually, yeah, that's not going to work for us. But we can click on the curve here and just sort of notch this down to that. There you go. And I think when you actually make the line, I think that's what, yeah, see, there's no point with this one. It just sort of went there on its own. It'll go to the 50 or the 150 or whatever it may be. It'll go to that. So when you put the trend line in, it's going to go on. It's going to go on its way, and it'll put the 0 in and all that. Or we could have had a very small, we could have come up here and just did 1/10% or something like that. We could do that kind of thing. But like I said, when I did it here, it hit the 50 or the 150. Which was the nominal profit. So if you're just the baseline cases, that's nominally what, with no time value. If there's interest rates are 0 for 3 years, you're earning 150 is what that really says. And actually, the math on that, how we did the math on, see, this one we did it. Yeah, the reason we were able to graph that And here, maybe I'll do it like this. We'll say, this is why we use the formula, I think. This thing at 4 plus NPV parenthesis the rate, and then you have all of your you have all of your cash flows. Parenthesis this plus this. You're gonna close it. Yeah, there's your 150. That's how we did it. That's why I use the NPV. So yeah, we can go a whole way with this. We can just grab the corner, pick it up, grab the corner, pick it up. But that's again if interest rates were 0 type thing, you'd be sitting there. But that's why again you have to be careful when you divide that. Use that summation formula. You divide it's 1 over r. You're dividing by 0, and it can get a little messy mathematically. Okay, we have the revised version of what this thing looks like. And now we're going to click here, and we'll do add trend line, polynomial to display equation, display r squared. Okay, so we're here with this thing. Right here, right there. And let's go red. Yeah, let's do red on that. Fill, and then the red outline. There you go. Okay, so we have everything sort of that we need, the blue, the red. We can format that equation in a bit. Let's not worry so much about that. That's 2 million, 1 million. We'll put commas in there. We could all the time. But we need to, like I said, the point of all of this, what the point of all this work was, we're going back to calculus now. The point of it, let me just make this a little bit bigger. The point of this was you wanted to see where these hit the axis down here. We see with the red now, IRR is 14 for the blue one. Yeah, about 14 and a third, sure. And in here, this is going to be IRR 12.56 if my memory serves me. Okay, and put a colon in there. Okay. But yeah, 12.56. That's that return, and that again, you're seeing in there. Now, actually, what we probably should be better to do. Let's do this. Let's do alignment like this, or make these things minus 55, and do instead of 2%, we do 1%. Yeah, we're good. Right, so if you look at this, right between 12 and 13, right, and then this is between 14 and 15. Yeah, okay, and actually this one, I'm going to make this thing a blue. That one a blue. There you go. Look at that. Okay, and here these numbers you can scrunch them a bit. Format the axis instead of 25,000. I'm sorry, instead of 50, go 25. So you sort of bunches them up a bit. And like I said, you can mess with the font of this thing. You can make this a 9 or something. Just to, again, have a little bit less. You care about your numbers, not so much the axis numbers. But there you go. There's your internal rate of return model. We spent a lot of time on this, and like I said, and it's always good to come out of this and you have an idea for something else. We have some other ideas here where we're going to look into numerical methods and all those other kinds of things. Actually, here, what you can do in here, you can just take this whole story, pull that out. You can take this whole story here, pull this out. Okay. You have your real, what's the answer, what's important type of thing. Those are your returns for those revised projects. And like I said, it's a thought process is what this all is. And folks, I appreciate your patience. I know I was sort of jumping in between versions of all this, and I appreciate you having the patience while I was doing that. So let's just bring this thing home a bit. Yeah, I'm just going to put it right over there. There you go. Okay, but there's your graph. So again, think back to what this looked like a few minutes ago, and think back to what it looks like now. And certainly, certainly you have a nice analysis here. And like I said, just to remind you of the math of these equations, as you move outwards, as these percentages get higher, the positive numbers those ratios get smaller, and the negative sort of takes over a bit, which is why the net present value shrinks. These are not scenario lines. Okay, the only important point on these curves is where it intersects the x-axis, is where NPV is 0. That's it. I just drew this through just to illustrate that point a little bit. But don't get confused that these are scenarios, which means, oh, I get a better percentage out here, but look my NPV, and you want to add the morals of the story is you want to add to the wealth of your balance sheet. Every time out. That's really what you care about doing. So, I'm not saying the percentage return doesn't matter, but you don't go to McDonald's and pay in percentage. You go to McDonald's and pay in US dollars, and you want to inflate that as much, make that appreciate as much as possible. Folks, we have another, and actually, down here, but before we even go anywhere, we have one last thing to sort of work on with this. You have the point of intersection of these two. Now, I have the equations here, right? We set them equal to each other and says find the point of intersection. So let's just quickly, before we sort of wrap this up, let's do that. We're going to have another video where it says, see what says valuing new computer systems. We're going to have another video where we work on that and talk about mutually exclusive, independence, and different proposals. This will be another video, out just a bit. But like I said, what I've noticed is I've made a bunch of these videos to keep. I get comments that they're too long, so let's just sort of keep it as is. But right here, though, we do have this last piece here. We have the equations, and want to find the point of commonality. So let's just sort of scroll up and quickly find that. Where is that? Is it underneath it? Yeah, it's down here someplace. Yeah, I think this is it. Yeah, it's not. We're not spilling over into the. It's just this stuff. So and you can see sort of where all that is. So let's. I'm just looking at what I did myself. Yeah, that was the initial equation, the revised equation, and we sort of ticked along a little bit. And yeah, we didn't set them equal and try to find the 0 point, but we just sort of found out where they were, where they hit 0 type of thing. Now, from the graphic, we can determine that it's somewhere between 11 and 12%. Okay, that's where these things intersect. Like I said, so as much mathematical detail as I can give you is what I really care about doing. So you're here with this thing. So what did we do? We came at 11%, which was right there. And equal this thing plus 1 divided by 10 percentage, Control D, right, which is right there. Again, the initial equation, it'll be now. Did I do this in numbers, or how do I do this? Yeah, I typed it in the. So forgive me instead of referring to. But let's for what this is. This is an extra thing. So just forgive me for doing it like this. I hard coded. This is what I did. There you go. And this is to the 1 power. It's just to the 1 power. 1. You don't want to have dollar signs for the whole length of what you're doing. Yeah. Okay. So we have that thing. So we're good there. And now the revised equation. And again, I typed it out. I typed it out. Okay. I typed the revised equation out, which is fine. Okay. So it's just this. So this was equal to parenthesis negative 75, 1, 2, 3, plus parenthesis 25, 1, 2, 3, divided by 1 plus the rate, right? The first power plus parenthesis 25, 1, 2, 3, 1 plus 8261, the second power, right? Plus the third thing is 25, 1, 2, 3, plus 450, 1, 2, 3, 1 plus T261, the third, right? I think, yeah. There it is. Again, so now you're looking for, where these points sort of, get common a bit. And we looked here, I don't know, I think somehow we determined just by visual inspection that it's somewhere in there. Okay, just by visual inspection. So 7, right? This is equal to this thing plus a tenth, no, 100th of a percentage. Right, yeah. Copy and the whole formula, all HDF, the whole formula went down there. 8 or so. Yeah. And then we just took this thing, copied the same formula here. Everything's already formatted, Alt HDF in there. We'll take, say, copy this thing, Alt HDF, which is in there. Oh, but there. So again, about 11.72, where these numbers are pretty close. Again, just by visual inspection, we looked at those. I probably should have had something that said, you know, differences or something, but this is about 50 something difference. You want to minimize sort of the differences as much as possible with this. So, right, actually, what are we doing here? Control 1, do a $sign here. Right, equals this thing minus that. All the way down and minimize this difference. Yeah, so somewhere in here I did this. Control 1. Okay. The font is a little bit small. It's not that important. Yeah, minus 30. Yeah, differences. Now let's put differences. Right, italics. Center it. Text. 10, something like that. And even these would make them italics. Look at that. You're doing some math. Okay, so 13 was the difference. So that's where we picked that MPV. Okay, but that's about, so at about 8,000 of an MPV, they were the same at the same spot. Okay, so look now, that's not MPV is not 0, obviously, because it's 8,000, but that's where we have the same MPV and the same internal rate of return. So there you go. So there's a lot of math in this, and like I said, we'll be sending these Excel files out as we go. Okay, but like I said, this is a big, a big hill to get over. We have another piece of this, so there's a lot of lectures that are involved in all these problems. So we're not going to rush through just to have a big long four-hour video type thing. So I'll maybe even later tonight I'll come back and maybe do this third piece of this. But there you go. You have all these pieces here. You have your numerical methods, and like I said, I'll be sending this out to you guys so you guys have an example of this. But I want you to try it yourselves, right? Just sort of give out the answers here. Okay, but yeah, you have a lot of stuff to look at, and like I said, the best thing to do is to watch these videos and just get some experience, working this stuff. Always, save your work. So again, this is the class notes for the online section. And these are my answers here. Okay, so I'm going to work on those a bit actually myself. So again, I'm always doing this. I'm always getting a better idea, for this or that, type of a thing, as we do things. Control D. Italics, fuller, 1, get rid of this, none, and this will be centered, 1, text, font, 10. Again, we're always getting a better idea, which is, I think, good artistic stuff. Lagerfeld passed away. I think you guys know who that is. He's a fashion guy who's been working in fashion for 5 decades. He's German, and he actually runs a couple different fashion investment situations that are just big entities. One's an Italian, and actually, or they may both be Italian, but that's unusual for a German to run an Italian sort of fashion house like that. But I read his obituary, and it was in the Wall Street Journal, and a big piece of it was that he was a creative, and the creativity. And I hope that we're teaching you to be creative with math and creative with all of this. It's not just grinding numbers. It's not just some accounting. There's an art to it, and certainly it's something that you want to look at in that particular manner. Like I said, the next video will pick up right here, which is example 8.1. Actually, what I'm going to do in the class notes. I'm just going to click on the class notes for a second. We're going to put a red bar just to remind me. What we're doing here. So we're here next time. All right, there. There it is. And we'll get rid of that next time. But that's just to remind me where we're headed with this. Okay. All right, folks. Enjoy viewing this. Let me save this. We'll be, now Blackboard, the video, for whatever reason, there's some there's a YouTube issue with the video production. So I'll be emailing you the videos until we can put them all up on YouTube, both the in-semester class and the online guys. So just monitor your emails for the video links. I'm putting it public on YouTube so you can find it. And there's our textbook. Okay, folks, I always like to look at the camera before we go. So, all right, folks, get in front of Excel, get in front of the videos, and you'll be working hard.